We know that the graphical representation of a linear equation in two variables is a straight line. In the coordinate system, such linear equations are called equations of lines. Equations of lines have different forms such as point-slope form and two-point form. Let's consider points P1, 1 and Q2, 3. Can you say which point lies on the given line? Let's extend the line. We see that the line passes through point P1, 1. Let's verify this algebraically. On substituting the coordinates of the point in the given equation, we see that the values of the left-hand side and the right-hand side are equal. In other words, point P satisfies the equation of the line. However, point Q2, 3 does not satisfy the equation of the line. Hence, for a point to lie on a line, it must satisfy the equation of the line. Now consider point P lying at the intersection of the two lines. Each of these two lines is represented by an equation. As the point of intersection, P lies on both the lines. Its coordinates must satisfy the equations of both the given lines. By solving these two equations, we get the point of intersection. Let us verify whether the coordinates of P, 5 and -8 satisfy the equations of both the lines. Substituting the coordinates of P in equations 1 and 2, we observe that the equations are satisfied. Let us start with equations of horizontal lines or lines that are parallel to the x-axis. Consider a horizontal line L that intersects the positive side of the y-axis at a distance a from the x-axis. The y-coordinate of every point on line L at any position is a. Thus, the equation of line L is y is equal to a. Consider another horizontal line S that intersects the negative side of the y-axis at a distance a from the x-axis. The y-coordinate of every point on line S at any position is -a. Thus, the equation of line S is y is equal to -a. Now let us find the equations of vertical lines or lines that are parallel to the y-axis. Consider a vertical line L that intersects the positive side of the x-axis at a distance b from the y-axis. The x-coordinate of every point on line L at any position is b. Thus, the equation of line L is x is equal to b. Consider another vertical line S that intersects the negative side of the x-axis at a distance c from the y-axis. The x-coordinate of every point on line S at any position is -c. Thus, the equation of line S is x is equal to -c. For example, consider point P. The equation of the horizontal line L passing through point P is y is equal to -5. So in general, the equation of any line parallel to the x-axis or a horizontal line passing through point P, h, k, is y is equal to k. The equation of the vertical line S passing through point P is x is equal to 4. So in general, the equation of any line parallel to the y-axis or a vertical line passing through point P, h, k, is x is equal to h. The equation of a line passing through a given point and having a given slope can be represented using the point-slope form. Consider a non-vertical line L passing through a given point P x1, y1. Let M be the slope of line L. Let A x, y be any arbitrary point on line L. Recall the formula for the slope of a line passing through two given points. According to the formula, slope M of line L passing through points A and P is given by y minus y1 divided by x minus x1. From the formula for the slope of a line, we get equation 1. A point A can lie on line L only if its coordinates satisfy equation 1. Equation 1 represents the point-slope form of the equation of a line passing through a given point x1, y1 and with slope M. For example, consider a line L passing through a given point P of 1, 4 and having a slope 3/2. Let us put the values of M and the coordinates of point P in the point-slope form of equation of a line. On simplifying, we get the required equation of the line as 3x minus 2y plus 5 is equal to 0. The equation of a line passing through two given points can be expressed in the two-point form. Consider a non-vertical line L passing through two given points P and Q. Let A be any arbitrary point on line L. Recall that 3 points are collinear if two lines passing through any two pairs of the given points have the same slope. Thus we can say that points A, P and Q are collinear if the slope of line PA is the same as slope of line PQ. Let this be equation 1. The slope of PA is given by y minus y1 upon x minus x1. Similarly, the slope of PQ is given by y2 minus y1 upon x2 minus x1. Let us put the values of the slopes of PA and PQ in equation 1. On simplifying, we get the two-point form of the equation of a line passing through the given points P and Q. For example, consider a line L passing through the points -1, 2, and 6, 4. Let us put the coordinates of the points P and Q in the two-point form of the equation of a line. On simplifying, we get the required equation of the line as 2x minus 7y plus 16 is equal to 0.